Okay, we want to continue our PowerPoint, and we want to talk about what is a mid-segment of a trapezoid. And you probably have a fair idea because it's very similar to what the mid-segment of a triangle would be. The mid-segment of a trapezoid is a segment that connects the midpoints of the legs. So in a triangle, we say it connects the midpoint of two sides. But in the mid-segment of a trapezoid, it has to be the midpoint of one of the legs joined to the midpoint of the other leg. It has to be drawn from leg to leg. And so, like I said, it's very similar to the mid-segment of a triangle, and you'll see in a minute some of the characteristics that a mid-segment would have. So Theorem 621, this is the mid-segment of a trapezoid theorem. If a quadrilateral or a four-sided shape is a trapezoid, and that's just any old plain trapezoid, then the segment is parallel to each of the bases. So the mid-segment is going to be parallel to each of the bases. And so we're representing that MN is parallel to AD. MN, again, is the mid-segment, is parallel to BC. And then the length of it is half the sum of the bases. So if I want to find the length of this mid-segment, I have to add my bases together right here. I have to add my bases together and then take half of that. Now the formula says 1/2. If you want to think about that as 0.5, that would be okay. So we understand that the base here, the mid-segment, and this other base are all parallel to each other. And if I want to find the length of this, add my bases and divide by 2, or multiply by half, or multiply by 0.5. So I want to find the length of this mid-segment. This mid-segment is going to go from X to Z. It's going to be parallel to these bases. So we're asking you to find X to Z. Well, I know that F to G is 26. Now that wasn't written on your figure. This would be written somewhere in the margin or in the instructions. So F to G is 26. E to H is 32. And I just have to remember that formula from the previous theorem. According to Theorem 621, the length of the mid-segment is half the sum of the bases. So if I want to find XZ, which is the midpoint, mid-segment, I'm going to take the two bases, add them together, and take half of that sum. So I'm going to say 26 plus 32, get that sum first, and then take half of that. If you're going to type this into your calculator, you need to do it exactly like this. Instead of 1/2, you can put a 0.5 there. But 0.5 parentheses, 26 plus 32, close your parentheses. If you aren't entering your parentheses like I am, then you're going to get the wrong answer. All right, here's a problem that's still concerned about the mid-segment, but it's an algebra problem instead of an arithmetic problem. So it says find the value of X. So in this problem, we know that we're going to use that theorem that the mid-segment is equal to 1/2 the sum of the bases. So EF is the mid-segment, AD is the top base, BC is the bottom base. I'm going to add those together and multiply by half. So now I'm using substitution. I'm plugging in 3x minus 2, and I'm plugging in x plus 1, and BC was 10. On the right side, all I'm going to do is simplify and get x plus 11. On the right side, I'm going to multiply everything in the parentheses by half using the distributive property. So that's a half x plus half times 11 is 5.5. Now, when we get to this point and we have that fraction in front of the x, none of us like to work with fractions. So we can multiply by that denominator of 2 and get rid of the fraction. So 2 times 3 becomes 6x. 2 times 2 is 4. 2 times a half is 1x, and 2 times 5.5 is 11. At this point, it's a simple two-step equation. I'm going to subtract x. I'm going to add 4. I'm going to divide by 3. So my answer there would be x is 3. Now you have to do a part of a review for tonight or for today. And this is just a Reteaching 6.6 part 1. And it's your lesson 49 on trapezoids. Trying to get the focus a little bit better there for you. Okay, so the main thing we need to talk about are the 4 main points from today. If I have an isosceles trapezoid, base angles are congruent. You should just kind of have that picture in your head. That's isosceles, and the base angles are congruent. Second, if I have an isosceles trapezoid, my diagonals are going to be congruent, and it's kind of hard to represent that in the picture, so I have that written over to the side. AC is equal to BD. Now those two pieces of information have to do particularly with isosceles trapezoids. The third one here is for any trapezoid, the midpoint is going to be parallel to the bases, and the length of that mid segment will be 1/2 the bases added together. So if I'm trying to find MN, I would add up QR, I would add to ZX, and I would take half of that sum. And then the last one is in any trapezoid, angles that share a leg are supplementary. So in this case, 1 and 3 are going to be supplementary, and 2 and 4, because they are leg angles. They are angles that share a leg. Now I'm expecting you to work the majority of this reteaching, but I'm going to do a couple of the problems. Now number 6 is not oriented the way we would think it would be. We would think about the base being like this, but it's not oriented that way, but we can turn it and think about it this way. If I'm looking at angle 1 here, there's that arrow. So angle 1 is a base angle to this 109. So angle 1 has to measure 109. Here's the leg. So 3 is its supplement, so that would be 71. And 3 is a base angle with 2, so it has to be 71 also. So if I turn it back around, you can see the answer there. In the next problem, it says to find the value of the variable in each isosceles trapezoid. It says show your work. And I'm not doing both of them, but I'm doing the one where I have the base angles are congruent there. The base angles are congruent, so that means 48 is equal to 5n plus 3. I have that 45 is equal to 5n, so n would be equal to 9. In the next problem, I have find EF in each trapezoid, show your work. Now that's where some of us are not doing what we need to do as far as showing our work. Okay, so make sure you're trying to do that. In this problem, I'm having trouble getting my paper oriented like I need it to be. If we can get the problem in there. All right, here I know that our mid-segment is E to F, and I know that it's 1/2 AD plus BC, which are the bases. This is just like the problem we worked on our PowerPoint. I'm going to replace EF with X plus 3. I'm going to replace AD with X minus 2, BC with 2X. I'm going to simplify that into 3x minus 2. I'm going to multiply everything by 2 to eliminate the fraction. So it becomes 2x plus 6 equals 3x minus 2. I will subtract 2x from both sides and add a 2. So x is 8. But now what the problem asked me to do was to find out what EF was. So once I found out that x was 8, I had to plug it back into the mid-segment formula. So 8 plus 3 would be 11. Now in question 13, it asked me to find the value of all of the segments. So I use that midpoint formula. I'm sorry, not midpoint, but mid-segment formula again. X is the length of the midpoint, 1/2. X minus 8 is the top base. 2x minus 12 is the bottom base. On the right side, that simplifies into 3x minus 20. I distribute that 1/2 and get 3/2 x minus 10. I multiply by 2, and I get I get 2x equals 3x minus 20. I'll subtract an x from both sides. I'll divide by -1, so x is 20. So going back up and looking at the picture, that means the mid-segment is 20. The top base would be 20 minus 8, which would be 12. The bottom base would be 2 times 20 minus 12, which would be 40 minus 12, which would be 28. So you need to make sure that you finish all of this reteaching and submit that as your lesson for today.